So hi, so we'll be watching today how to create the symbol of a particular circuit, and of that symbol, how to use that in the multiple circuits. So we'll be opening up the terminal to start with the process. Yes, file, open, go to your library, open the circuit. Okay. I believe that you have already created a NAND gate circuit, right? Usually we all create a NAND gate circuit like this. I'll delete this. I have a wire over here. See, usually we create a NAND gate circuit like this, but remember, whenever you are supposed to create the symbol of a circuit, never ever take two signals with the same name. If it is the case in your circuit, please short them and keep them one name, right? So what I'll do, I'll delete one of them. I'll delete this one to create a symbol. I'll take a wire and I'll connect this here. Now I have shorted this point and this point so that I can have only one signal. If I need to run the circuit, I can have the two separate signals with the same name. But in case I need to create the symbol of the circuit, then I need to short it. Second, you should not have any ground or voltage source in the circuit. Correct? Now we'll create check and save. We see there is no errors in this. Now we'll create the symbol. Create cell view from cell view. This is showing library name, cell name, schematic symbol, and then OK. Now it is showing you that which pins you want to keep on which side. In the NAND gate, usually I have the V out on the right side and my pins A and B on the left side. This VDD remains on top. So I'll place VDD on top and will place ground at the bottom. I have cut pasted so that the name or this capital letter or small letter should not change the way I have given it in the circuit. So now what I'll do, I'll press OK and this screen opens up which will ask me to create a symbol. Now I'll delete its external parts, this. and this instance name. I'll select this, press Q and name it NAND. Okay. Now place these names close to the red pin so that you can effectively create your symbol this way, right? Now I'll try to create the symbol over here, the symbol of NAND gate. How an AND gate looks like. I'll create an angle this way. Now I'll take this, rotate it, this way, and then now this looks more like the NAND gate. This way, right? Now to this NAND gate, I'll put the VDD on top, ground at the bottom, its name NAND gate here, and this whole V out here, and these two input pins there. Now your NAND gate symbol is ready. Now you can always save it and close it. You can close this also. Now we'll try to test it. We'll take new cell view. Now I want to use NAND gate as AND gate. I'll select my library in which I was working and I will write AND gate. Okay, so there is new cell view. I'll take browse, my library, NAND, and the symbol. See, if you will select the view as a schematic, so you will see the schematic here. If you will change it to symbol, you will start getting the symbol of that schematic, right? How do I create an AND gate? I can take this way, and now I can use the shorted A and B and get it connected with anywhere, right? So what we'll do, we'll short its VDD, and after shorting it, we'll give a VDD here Same way, we'll short the grounds and we'll place the ground pin here. I rotate these pins by pressing R into my keyboard. Now I'll take the V out. This is the V out pin. V out with the direction output this way. And there are two more pins required. One is A and the other is B. So I'll take it as input, name it as A, rotate by pressing R here. I'll take B, rotate it and place it here this way. I hope all of you got it. Now we'll simulate it using ADL. How do we simulate it? We'll take ground as DC, 0 volts, VDD as DC, let's call it X variable, right? Now A and B should be taken in such a way that it can produce both 0 0 0 1 1 0 and 1 1. So how I'll take it? I'll take A as bit with one value X, 0 value 0, rise time 1 femto, fall time 1 femto, period 20 nanosecond, and the pattern will be period. Let's take the period 10 nanosecond, and pattern will be 1100, right? Apply. Now I'll take B, type is bit, 1 is X, 0 is 0, rise time is 1 femto, fall time is 1 femto, period is 10 nanosecond, and the pattern data is, there we have taken 1100, here we'll take 0101, so that we can cover all the instances. Apply. Now see, we have taken one bit for 10 nanoseconds, right? We have taken one bit for 10 nanoseconds. So there are 4 bits. So how many nanoseconds we require? We require 40 nanoseconds. So we'll apply, we'll edit, and we'll place X, and we'll run the circuit on, say, 0.8 volts. Okay. Now we need to run the circuit for at least 40 nanoseconds as we have discussed. Apply. Okay. Output to be plotted. Select on design. We need A, we need B, we need output. And now the time to run the circuit. Since the circuit is running for the first time, it will take more time. Second simulation will take lesser time. Let us see how it is behaving. So this is A, B output. In the AND gate, for this A is equals to 1, B is equals to 1, the output is 1. Otherwise, the output will remain 0, right? For the combination of this A1, B1, the output is 1. Otherwise, the output will remain at 0 volts, right? At the logic 0. Now let us take the NAND gate. See, this is the output. Vout is the output of NAND gate. And since here you have applied NOT gate, so you are getting AND gate. So why not we see the output of the NAND gate also? We place a wire over here. Let me do it again. And we'll apply output pin here, and we call it NAND output spelling. This way. And we try to check this output to be plotted. Select on design. We'll select this also. Now, if we run this should run a bit faster than the previous one because this is the second instance. So you see the output of NAND gate is exactly opposite of output of AND gate, right? So where you have both 1, 1, the output of AND gate is 1 and NAND gate is 0, right? So now in that we have seen the implementation of a symbol and implementation of symbol in a circuit. We can always find out that how a symbol behaves with respect to power dissipation, with respect to the delay, that we will discuss in the next lecture. But I would request that you create a similar circuit for the NOR gate or any other gate, and try to create OR gate. Now what I can do is I can create the symbol of say AND gate from here, right? So you can also create the symbol of AND gate from the 6 transistors. You can use see you have the circuit of NAND gate, from where there you can create the symbol of AND gate also. I would request take the symbol of NAND symbol of this NAND gate, make it in another cell view, and then put a inverter in front of it and create a symbol for the AND gate. Now you have NAND gate. With this NAND gate, you can create any circuit. Like you can create flip-flops, you can create adder, you can create subtractor. I would request you have NAND gate in front of you. You create the half adder or full adder with the usage of it, right? So we'll meet in the next class. We'll try to create the circuit for this half adder or full adder with the help of this, right? So till then, thank you.